Okay, welcome. This is to the second part of your landforms at plate boundaries. We're going to look at volcanoes today for this section here. So basically, volcano is a landform that is formed due to fracturing on the Earth's surface, the crust itself, which allows magma to come onto the surface itself. When you hear people talk about the concept of volcanicity, you're basically looking at upward movement of magma onto the Earth's through the Earth's crust and onto the Earth's surface. So the process of making volcanoes. Now what you see in this diagram here, figure 2.38, is what you have as a cross-section of a typical stratovolcano, including things like the ash plume and the rock fragments that are ejected during an eruption itself. So this is a fully labeled cross-section diagram of a stratovolcano. Now the shape and size of volcanoes are largely due to a concept that affects the type of lava that you see. It's called viscosity. Viscosity refers to the stickiness or the resistance to flow of the lava. Think of it as high viscosity is something like honey, so when you pour it out it flows slowly, whereas low viscosity is something like water, so when you pour it out it moves very quickly. So the item that affects the viscosity is the level of silica within the magma itself. So if you have a low silica type of lava, it is basic lava and low in viscosity. So if you have a high amount of silica content within the lava itself, you will have acid lava, which is high in viscosity, so it will layer up and as a result form stratovolcanoes. So you have basic lava forming shield volcanoes and acid lava forming stratovolcanoes. Now, besides viscosity, how else can we compare the two different types of volcanoes? Basically, we can do cross-section comparison. So, through drawing the cross-section, you will be able to see that they are vastly different type of volcanoes. If you talk about the exterior look of the volcano, for a shield volcano, it is generally gently sloping along the sides. It has mainly one vent and a crater on top. There is no secondary pipes, etc. It is built up of layers of ash and lava from successive eruptions. Now, how you end up with this particular shape is because you have basic lava here. Basic lava is fast flowing. Remember, we talked about it being like water. So when it erupts, right, it's able to flow fast away from the location of eruption near the fracture itself, near the crater. So as a result, it has a very broad base, gentle slides, and low overall height in comparison to a stratovolcano. For the second type of volcano we are looking at is the stratovolcano. Stratovolcano, as you can see from this cross section here, is made out of more components. You have your secondary cone, the secondary pipe, the main crater. You still have layers of lava ash and other fragmented materials, and what you end up having to show is things like the lava, the ash that comes out. Sometimes you can include things like your ash, the fragments that are ejected. Now, what causes this particular dramatic shape volcano is largely due to the type of lava that is found here. You have acid lava, which is high in viscosity, high in silica content, so it doesn't flow far away. So whenever there's an eruption, right, it's allowed to stack up and create a high overall height with a very steep sides along the sides. We talk about the type of eruption that you experience at a stratovolcano. Because it doesn't flow far away, the ejected magma material is allowed to clog up the area, so the pressure that is built up at such sites tends to be very high, so you tend to have very, very explosive eruptions, creating things like pyroclasts and volcanic bombs. Now what you see here is basically a pyroclastic image of a pyroclastic flow, which is superheated gas and ash that is streamed down when there's a volcanic eruption from a stratovolcano. So when you're covered by pyroclastic flow, you actually burn, right? It's very, very hot and you will burn to death. The second image that you will see coming on the screen is an image of a lahar. Lahar is basically your magma material mixing in with glacial ice and forming a type of superheated mud flow that will flow down and destroy everything within its path. So lahar is fast flowing and destructive in its nature. As with fold mountains and block mountains, with volcanoes, you can be also given a map like this and shown location and asked to describe distribution. So once again, distribution, talk about it in terms of cardinal directions. Where does it move from? Does it stretch to the north, the south, east, or west? Talk about the plates that are involved, the type of plate margins that you find volcanoes occurring. You are required to label the plates that form these land features where you find these volcanoes. Important things like your Pacific Ring of Fire, where you find your subduction volcanoes, and where do you find your rift volcanoes along your divergent plate boundaries, where the African plate is splitting apart, or where you have the Mid-Atlantic Ridge splitting apart, oceanic divergence, or continental divergence. So here we go. That's basically what we have to talk about for volcanoes. For more information, please refer to your notes, and remember the two main types of volcanoes we need to look at. Also note, besides distribution type questions for volcanoes, you can also be tasked to explain how it's formed using the aid of a fully labeled diagram. That will mean that it requires you to draw the cross-section of the type of volcano you're talking about. In terms of formation, you need to talk about the types of lava that's found and peculiarities with regards to its overall shape, as well as maybe even its explosive nature or lack of. I hope this video actually helped you clarify some of your doubts that may exist as with regards to volcanoes. The next video that will come along will touch about the benefits and the disadvantages of living near volcanoes. Okay,